All right, picking up on number 4. That's where we got to on this handout. 2 cars at state start from the same location, and this problem they're starting at the same time. One travels north at 80 miles per hour, and the other's that's north, and then the other travels east at 60 miles per hour. And so the question is, at what rate is the distance between the cars changing 15 minutes after they start? So let's start here with a little drawing. See if we can get all this this little space here. So if I draw out the picture here, they're starting, let's see, one's going northeast. Okay. So if I've got here's my starting point, and one car is going north at 80 miles per hour. So let's call that car X. And then the other is going east at 60. Okay, so let's say that's Y. And when I say that, by that what I mean, X, let's let X be that distance traveled. You know, they're going to go so far after so many hours. So X and Y are those respective distances. All right? So what's the question? The question is, at what rate is the distance between them changing? And so the question is, what about this distance right here, which we will call Z? We want to know a little something about that distance. Okay. What do we want to know about that distance? Well, it's one thing, we can find the distance, but that's not what this is asking. What are we asking for here? If Z is the distance, we want to know at what rate is the distance between them changing 15 minutes after they start. What is it we want to know there? The derivative of Z. We want to know the derivative of Z, so the dz dt is what? Isn't that Z being the distance between the cars? I'm wanting to find out what dz dt is, the rate at which the distance between them is changing. That's what I'm looking for. Okay. Now, as we have in previous problems, let's go ahead and label what we got here. What about this 80 miles per hour? That's how fast the car going north, which was the X, the one I called X distance. What does that tell me? It's 80 miles per hour. Isn't that the rate of that car going north? Well, in our terms, what do we know about it? How would we label that in our calculus terms? Isn't that the rate X is changing with respect to time? It's dx dt. dx dt we know is 80. Yeah, and so these rates of travel, you know, how fast a car is traveling, or airplane, or whatever it is, the rates are going to be ddt's. In this case, the 80 is dx dt. What about the 60? What would that be? That'd be dy dt. Okay? That's okay. So this is what we know, and then what about this? Let's go ahead and talk about the 15 minute. What is that? Wouldn't that be the time, t? But we should note here a discrepancy between the time and the rates. What are the rates in units wise as far as the time? Aren't the rates in hours, whereas the time is in minutes they're given? So I probably want to change that to t to be what? What would t be in hours? Well, 15 minutes is a quarter of an hour, 0.25, divide by 60. Yeah. You might have to do that. So be sure to know that the rates should match up with the time units. So if it gives it in minutes, be sure to change it over to hours or vice versa. Okay. All right. Okay. So we got that's our known information. Remember when we were going through the previous problems on the handout there? We did write down stuff. The given information, probably the added feature on this one is, first thing we did here was draw a picture. So sometimes maybe drawing the picture is the first thing you want to do. But then we labeled it. But what do we do after that? Well, we go back, and I've got them right here stored. So what did I do on number 3? Well, number 3, I labeled everything I had, and then what did I do? Put a little formula. So I need an equation or formula. It's more equation on this one, I guess. So step 3, we drew the picture first, then we labeled all of our information step 2. Then, so step 3 here is going to be, let's write down a nice little equation if we can. What equation do you see happening out of this here? What have I got right here in my drawing? It's a right triangle, isn't it? And what do we know about the right triangle? Well, in the right triangle, there's a relationship among the sides called the Pythagorean Theorem, or related in the Pythagorean Theorem says a squared plus b squared equals c squared. Well, in this case, I used x, y, and z. So don't I have here x squared, my equation would be x squared plus y squared equals z squared? Pythagorean Theorem. Yes. We are going to utilize Pythagorean Theorem a little bit on our related rate problems. Here's one example. Okay? All right. So we got our equation. What's next? What do I do next? Well, I'm interested in finding this dz dt, right? So what would be the next step? Wouldn't it be d dt both sides here? Take the derivative with respect to t? Yeah, d dt those guys. So what's the d dt of x squared? Well, the derivative would be 2. Bring down your power. Subtract 1 from your power, so 2x. But I'm doing the derivative with respect to t, so I also need what else? I need dx dt, don't I? Then for the y squared, about the same deal. Derivative, it's 2y. But I also need dy dt. Then on the right side, I've got 2y, a z squared, so it'd be 2z dz dt. With me so far on that? Okay. Now, one nice thing about on the Pythagorean Theorem ones is, do you notice here if I could factor off a 2 and then cancel out? All these are divisible by 2. Let's just mark those little 2's out. Basically dividing both sides by 2. So I wind up with x dx dt plus y dy dt equals z dz dt. Okay? All right, so now I'm ready to substitute. I'm trying to find dz dt. I got dx dt. I got dy dt given. Let's just go into substitute. All right. Now, though, there's a couple of other little notes here to mention. I've got dx dt. I've got dy dt. I'm going to substitute in. But what about I'm trying to find dz dt, so I need to know these other things. What about the x? What is x again? X is this distance traveled from the starting point to wherever it would be in 15 minutes. How do I get that? Wouldn't x, x is a distance, and distance is rate times time. And my rate here is 80. What's my time? 0.25. So isn't x 80 times 0.25, which is basically divided by 4, wouldn't x be 20? So in this particular case, that x distance is going to be 20. What about y? Well, y is the same thing, except y is the distance going this way. So y is going to be its rate which is 60, times its time, which is also 0.25. So that's going to be y is 15. So let me redraw mine. I've got a 20. Put that. 20. Try to erase that. Okay. All right, I got 20. Right here. Here, 15 here. So that's my x and y. So x is 20, dx dt is 80, y is 15, that distance. dy dt is 60. Uh-oh. I'm still lacking one thing, aren't I? Trying to find dz dt, but this equation here, this d dt equation, still has z in it. What are we going to do there? Well, isn't z this little thing right here? And don't I still have the relationship, the Pythagorean Theorem going there? So I can figure out z, just go back to the original x squared plus y squared equals z squared equation before I dt'd it. And so I've got 20 squared plus 15 squared equals z squared. So I can figure out what z is. So z, you've got 400 plus 225 equals z squared. And so 625 is z squared, so what's z? Z's square root 625. I can put that in for z. Is that okay? Now I can get my dz dt, solve for here. This is 1600. 20 times 80. 15 times 60. Is that 900? Equals 625 square root dz dt. So that's 2500 equals the square root of 625 dz dt. Divide by the square root of 625. And so I get dz dt, because that cancels those out. So dz dt is going to equal 2500 divided by square root of 625, which if we want to round that off, what do you get? 2,500 divided by the square root of 625. Oh, square root of 625 is 25, isn't it? I should have done that before. I was thinking that square root wasn't a nice one, but that square root of 625 is 25, so 2,500, that is 100. What are my units? Well, the units of z would be miles, just like the x are and the y are. And the units of time are hours, so it's miles per hour. Or mph, if you prefer. With me? It's okay. All right. Now let's try number 5. I think it has a little twist about it compared to that one. 2 cards, it says, start from the same location but at different times. One travels south at 48 miles per hour. The other travels leaves 30 minutes later and travels east. All right. So let's make south go this way. So I got one car leaving going south. The other travels east at 55. Okay, well, basically the same, because this guy's going to go this way. However, let's interpret it this way. Basically, what I could say is that the car going south had a bit of a head start. So let's say that one, when that one got there, then this one started going east. Okay? and we can figure out, and the one going south is going 48. So let's just start. We'll just start our time. Yeah, the time is going to be 2 hours, and that's after the second one leaves. Because really the first one left, 30 minutes earlier, so the second one traveled 2.5. But here's the way we can do this. Let's call this part here x, just meaning this part. But the x got a little head start, isn't it? How much of a head start? 30 minutes? So how much would that be? If it's traveling 48 miles per hour, its head start would be 48 miles per hour, so it'd go 48 miles in 1 hour, so it'd go 24 in 30 minutes, half an hour. So it got a 24-mile head start. And then the y would just be that. With me? Yeah, just take that as a head start. All right, so same question, how fast is the distance between them changing after 2 hours after the second one leaves? So I'm still looking for that tied in with that z right there. Okay, so we do know, again, dx dt is 48. dy dt is 55. And I'm looking for dz dt. Time is 2 hours. However, what about my equation? Again, I'm going to use Pythagorean Theorem, but there's a little bit of a change here. It's not x squared plus y squared equals z squared. Because of that head start, isn't this the a, if you will, of the Pythagorean Theorem? What's a? Well, a is the x distance, but it's also 24 miles with that. X plus 24. So yeah, this total side here is x plus 24. So that's got to be my a. X plus 24 squared plus, and then the y is just straight up y squared, and then z is just z squared. With me okay on that? All right. All right, this is good. So that's the change here that with that head start. Got x plus 24 there. All right. What's next? Well, I'm looking for dz dt, so I better ddt both sides, okay? ddt them. So the derivative with respect to t. Well, we start off with an interesting one here. How am I going to ddt that? Well, there's a couple options, but the best option would be chain rule. What if I use a chain rule here? What would I get if I used a chain rule? Well, bring down the power. This is my outside, so bring down the power. Subtract 1 from the power, so that's 1. But then I have to do the derivative of the inside. Which the derivative of the inside, what would be the derivative of the inside? Well, the derivative of that's 0, but the derivative of that would be 1. But what else do I need? I'm doing the derivative with respect to t, so don't I need a dx dt there? So 1 dx dt would be the derivative of the inside. Is that okay? See where I got all that. All right, now, what about the y squared? Well, that's 2y dy dt. And then the z squared would be 2z dz dt. Now, I believe I am ready to substitute in. Just go back here and do a little calculation. What is x? Well, x is the rate of x, which is 48, times the time, which we started time ticking right here, so that would be 2 hours, which is 56. So x is 56. 96, sorry. The y, that's going this way, which is 55 going east, so it would be 55 times time, which is 2, which would be 110. Okay, so right here, before I substitute, I can cancel out those 2's again. Everything divides by 2. So I wind up with x plus 24 dx dt plus y dy dt equals z dz dt. Okay, so plugging in the x is 96, so it'll be 96 plus 24, 116. Dx dt is 48. Y is 110. Dy dt is 55. Which only leaves the little matter of z. How do we get z? Back to Pythagorean Theorem, right? Because again, if x is 96, then this side here is, what have we got? What do we say, 116? No, I messed that up, didn't I? X, this is 96, plus 24 is not 160, it's 120. Sorry about that. Try to get that out of there. This should be 120, sorry. Makes it better anyway. Okay, so this side is 120. This side is 110. So I can figure out from Pythagorean Theorem what z is. So 120 squared plus 110 squared equals z squared. See, 120 squared, 14,400. 110 squared is 121,000. No, 12,100, I should say. That equals z squared, so add the 14,400. 26,500 is z squared. And so z is square root of that. And let's just leave it as square root of 26,500. We'll round it off here in a minute. With me okay? I do that right. Z is the square root of 26,500. Put that up here in our little equation. All right, so 120 times 48 is 5,600, 5,760 plus 110 times 55, 6,050. That equals the square root of 26,500 dz dt. So 5,060 plus 6050 is 11,810. And then I'm going to divide by the square root of 26,500, right? That'll get dz dt. And so round that off. I'm getting along about 72.5 miles per hour. How's that look? I do that okay? Anybody else get that? What you got? Okay. All right. Question or anything about that one?